Hello everyone. The next project in machine learning is Spotify music popularity prediction. So we can find out the which music is got popularity. First, you will have installed this library. Next, import this library pipe forest. It's working. The next is the df variable, then pd dot read csv, and this is the file path where I pass the df dot head. It means it show the 5 rows and columns. So you can see the output of the data. This is the data: unnamed, track name, artist, album name, album id, track id, popularity, release date. So this is the, it show the only 5 row because had show the only 5, and 22 columns. df dot info, it show the data types. The it is integer type, unnamed, track name, object, artist, all these object type, explicit, boolean type, energy, float 64, density also float 64, like all these data types. Shape, row, rows and columns, there is two, 227 rows and 22 columns. Now find out the null value. So there is no any null values. Now the next is I drop the column unnamed z unnamed 0. This is the column name. So there is a, you can see that this is the column, this whole is the column name. Now drop this column. So df, then drop, then columns, the column where there is a column name, k name, and axis for column is equal 1. So you can see the, it drop the column name. Second, where is first is the unnamed, so second is track name. Now you can see the output, it show the track name first. The next one is want to see the number of unique values, all these data set. So explicit has 2, more 2, key 12, df dot number, n number stand for number, unique value dot sort values, so column names, and these 5 column names data types is float 64. So you can check. Then if you check, this is the danceability is a float type, energy float type, then loudness float type, speech speechness, all these float type. These 5 are the, you can, energy, loudness, velocity, and violence. These are all float 64. And there I have used the loop for where is a variable I, then in I pass the these column name, this column come into the call. in I will. Then give the visualization using the PLT dot figure. Then fixed size is 12:9, and then SNS dot scatter plot, where I pass the data is a data set name, and X I pass the I, this one is the I, and Y use the popularity. This is also the column name, and then PLT dot show. So you can see the popularity of the danceability. So this is the first. It show the 5 scatter plot. This is the danceability. The next one is the energy, how much the energy level is. Then third one is the loudness. So there is a this portion is the loudness. So it give the property popularity wise all column. The next one is the using the histogram with the distribution music. Same thing is I using the loop, where I pass the I and pass the column name, all 5 columns which have the data type float 64. Then PLT dot fixed size and figure, fixed size is 10 or 10 and 7. Then SNS dot hist plot and data frame name, where I pass the I and KDE equal true. So KDE KDE is stand for the kernel density estimate. It is the method, or it used for the visualization or distribution, and also it represent the probability density. So you can see the distribution of the music. It count the value. There is the density is 40, and then is this less than the 30. The next one is the same is energy level. So energy is the 35, then 30, the next is the loudness. Loudness also reach the 40. Next is the acousticness. So it also go to the above to 70. Then is less than 20, somewhere it found the 30, and variance is 40. Then all is less than or 35, then 30. So this is also count the value and music, distribution of music. The next one is I have taken the variable call, num call. You can take anything, where I pass the data frame name dot select D types, मतलब it select the all data type include include the float 64 or int 64, which column has the value of float 64 as well as int 64 dot columns. So now you can see, if so it show the, sorry, so it show the columns or int 64. The next one is the also plot heat map plot PLT, then figure, then fixed sizes. I have given 25 and 20. Then SNS heat map df dot, oh, sorry, the next one is, if I comment this, then I have taken the new variable num df equal, then df num, and then call num call, where I pass the this num call and print the num df. Now you can see the next one is the using the correlation. So this is the variable name co, and then num def, this is the this this is the variable num def I pass, and then dot c correlation and pass the print the variable name. So it's take the all which have the floor 64 or int 64. So it give the correlation between float 64 and int 64. Now visualize this all this data, then PLT dot figure fixed size is 28 520. You can uh, give anything. Then SNA dot heat map sorry, df dot correlation, that is a variable, then annoyed to equal true, then vm equal -1 and vmax equal 1 and center equal 0, then plt dot show, then vm means होता है means view port minimum और vmax means viewport maximum. So this is a vmin represent the smaller value of viewport, like a width and height. If I have given the -1, that it show the percentage value or represent the highest value to view the port width and height. So you can see the output is this popularity duration, all these column name which have the data types is floor 64 or int 64, and there is the value is 111. it means 1 means it is a positive values. The next one is the where I pass this module from scalar underscore selection import using the train and testing split, then import standard scalar, then next one is the assemble dot import random forest regression, and last is the matrix where we use the mean square or error r2 square. So it's working now. The next is using the normalization where I pass the same call variable name, then I pass the all 5 column which have the value is float 64, then print this one, then you can the output is it show the output only. So x, then df where I pass the data frame call and print the x. So now you can see the output, so it show the all 5 columns output. If I comment all these and now see the popularity, where y or data frame where I pass the popularity and print the y. So now you can see the output, so it show the increasing order. So 96, then 94, 91, all are the popularity, the one by one this song has the popularity, first this 96, then 94, all these now. Next one is the splitting the data is a x train x test y test equal train test and split where I pass the x and y, and test size is equal to 0.5. Now it means that 75% is training data and 25% is the testing data, and random state is equal to 0. So it's working. Now we want to see the shape of the train x train dot shape. You can see the 170 and rows and 5 columns. So you can use it all these y train dot shape and x test dot shape one by one. You can try it. The next one is the standard scalar. So is create the method sc equal to standard scalar and then print the it show the standard scalar. A standard scalar used for the remove the mean and scale each feature, or you can say the variable to unit variance. Now x where I pass the this is the variable name sc, and then dot fit, then transform the x train and print the x. So after transform the data, the output is like this. Same is if we use the x equal is a method variable name dot transform x test and print the x. So the data should look like this after transform the test data. The first is the extrain and second is extest. The next one is the random forest module, using the module random forest. So RF, I have taken the RF variable name where I pass the random forest. You can use the simply random forest and pass the n estimator 100, or you can also customize the random forest according to which is suitable to you. That time I am customize the random forest. That's why I am using the n estimate where I pass the sum argument 100, max depth 2, random state 0, min sample split equal to min sample leaf 1, and max feature equal auto. You can give auto square anything. So there are some parameters you can pass it, like an estimator. This is the parameter. The number, an estimator means number of decision tree in the forest. Max depth means the maximum depth of the decision tree. Minimum some sample is split, also the number of sample required to split the node. Like this you can use these type of parameters. Now using the fit the data, so fit the model. So you can see the, it show the random forest max depth 2 and random state 3. Now next one is the predict the data. Now when testing the data, after test the predict the test data. So test data, after testing the data, look like this 63. Some are same to like this. This is the same, this is the same. After testing, some values have the same. Now mean square, using the mean square. So mean square, this is the variable name, then pass the mean square error. Mean square used for the mean, or is defined as the mean or average of the square of difference between the actual estimate value. So mean square is 38.64 something. And then same is r square. R square value show how the model predict the outcome of the dependent variable. So this is the 0.2569. So it r square range mostly 0 or 1, so it show the 0. So that's it.